Okay, today I want to go over a brief review of some of the things that we learned back in Research 1. Some of the theories and concepts that I'm about to go over, you'll recognize, you'll remember, you'll say, oh, I remember that from last time. Some of you, it may take a minute to kind of dust the cobwebs off, but these are the things that are going to carry with us through this semester, and I want to make sure that you kind of have a good idea of what we need to know from a baseline standpoint. So from a theoretical standpoint, it's very much dependent upon your focus. Some of you have strong backgrounds in research. Some of you have strong research interests. Some of you are just pure curious people. If you're constantly questioning things, then you're a very inquisitive mind. You're seeking to find answers. And some of you are just content with this is the way it is because that's the way it is. And that's not necessarily good or bad, or being a very curious person isn't good or bad. It just kind of affects how you're going to approach some of this material. Again, go back, skim through. The chapters in this book are very short, they're very sweet, they're very to the point, so you should be able to go through that, especially if there's something very specific that you're missing. So one of the first key words that we want to make sure that you understand and remember is empirical. Okay, you've probably heard this before. People talk about it on TV, they talk about it in casual conversation, but empirical research is basically something that draws conclusions based on hard evidence or data rather than conjecture or speculation. Empirical evidence is actually going out, collecting data, and coming up with some kind of answer. It's not going back in time. It's not using a lit review to come up with a theory based on research that other people have done. Empirical evidence is active research that's gone on, active results. Telling the difference between the two is not very difficult. Now, from an operational standpoint, most of you have already been doing this also, okay? Concepts are great, okay? But if you can't measure an outcome, you're never going to know what happened or why it happened. So when we have to think about research and how we're going to do things, many of you came up with some great ideas, and the response to some of your great ideas was, well, how are you going to measure that? Well, operationalizing essentially means figuring out how to do research, okay? Figuring out how to measure it. So if you want to measure, well, mental toughness is the thing that always comes to mind. How can you measure mental toughness? How do you know? How do you measure that someone's gotten better or gotten worse? And again, the big argument against it from a scientific standpoint is, okay, well, if you measure it because they got better, then every single person that does this is going to get better at equally or more or a higher rate. And so there's a lot of things in the world that we kind of try to operationalize and try to measure, and we're unsuccessful. So sometimes coming up with the way to measure a research project isn't necessarily very difficult and complex. Sometimes we're just not answering or asking the right question. And so we'll go through that. And with each of you, we work through your research questions and ultimately coming up with your hypothesis and how we're going to get that rolling as the semester progresses. Now, sometimes we do make it very difficult on ourselves. We try to rationalize or operationalize performance. We try to come up with why we're winning, why we're losing, why is someone's skill better than mine. Sometimes it's just because their genes are better. They have better parents, they have better background, maybe they have better resources, some kind of effect. Well, how do you define the effect on something? Some kind of change. Again, if you have a very specific defined area that you're interested in, and I hope one of the take-homes that you got from the case study class is that the more specific you can get, the better it's going to be. And an influence is how can you tell what influence one person had on another, or what influence something had on someone else. If you were to take 12 people in the room and gave them a big slug of a narcotic drug, is it going to affect them all the exact same way? Maybe it's a hallucinogenic drug. Is it going to affect them exactly the same way? And the answer is probably not. Now, from a variable standpoint, and this is one that we all need to be on the same page with, you have independent variables and you have dependent variables. Now, the independent variables, those are the ones that stand alone. They're not affected by the treatment. They're the actual thing that we are causing. And so the dependent variable, that's what's exactly affected by the independent variable. So if I said using fertilizer helps to grow a plant, well, I would have some plants. So the independent variable is going to be fertilizer, non-fertilizer. Your dependent variable is plant growth, because the plants are either going to grow tall or they're not going to grow tall. And that's how you're going to measure. The dependent variable is essentially how are you going to measure the focus of this research or the focus of this project. So it's I think all of you are going to see this in a different way. And so hopefully you're going to come up with your way of trying to figure out what exactly that is. As before we get too far in this semester, if you're confused, please let me know that independent and dependent variables do not make sense to you, because we've got to figure out a way for you to understand it. And if it's giving you specific examples that make sense to you, so you can always refer back to that one as kind of your base, that's what we'll do. But independent and dependent variable, very critical. Now, we measure variables different ways. Okay, types of variable measurement, we have nominal, ordinal, interval, and ratio. Ratio is pretty much equal units of measure based on some type of order. So that's pretty good. Interval, equal measures between numbers. We think of interval timers. We think of an interval between, we'll wait 2 minutes in between sets. That's fairly simple. Ordinal, you think about rank. First, second, third, fourth, fifth. No real specific difference between numbers. It's just you came in first, you came in second. What the difference in first and second is 1.5 minutes, and third and fourth is 6 minutes. It doesn't really matter. You came in first, you came in second, you came in third, you came in fourth. And then nominal, basically groups are placed into categories with no assumed relationships. So remember, when we talk about the types of variable measurement, they're pretty much going to fall into one of those 4 categories. Now, moving on to probably the thing that we will deal with the most in this class is reliability and validity. Now, reliability, again, is repeatability or consistency. Being able to repeat the same thing over and over again and get the same result is the essence of reliability. Using your methods, I should be able to take your project and take your methods like a cookbook instruction and make the exact same project and get the exact same results that you do. If I don't, then we have a problem. Now, validity is whether a measure is actually measuring what it's intended to measure. And we're going to talk a little bit about face validity in a moment, but for a lot of you, from a survey standpoint, you may, or if you're going to create your own measurement instrument, you may want to go the route of face validity. And we'll talk about that in just a moment. Now, one thing to remember is that you can have reliability and not have validity, meaning something is reliable and repeatable, but what you're intending to measure, you're not getting the mark. So let's look at an example. So if 3 archers are shooting at a target, our goal, our ultimate goal, is to measure the archer's ability to hit the bullseye. So we know that if we hit the bullseye, that's very good. That's our goal. Well, on the scatter plot that you see on the left, you see that the individual did not hit the bullseye with any of the 3 shots. Is this repeatable? No. The 3 arrows are in totally different places. There's no consistency there at all. Is it valid? Does it show that now what it does show is that the individual is not very good. But if we're trying to show validity, that if we say that by wearing these yellow glasses, this individual can hit the bullseye more often, well, this obviously is not what's happening in this picture. So if we change it up and we say, okay, 3 archers shooting at a target, the goal is to measure the bullseye. 3 of these shots are all clustered around each other. Visually, you could say that that's very reliable. Now, this semester, we're going to learn how to statistically confirm what your eyes are telling you. So right now, we look at that, and visually, we say that's very reliable. The goal is that with these yellow glasses on, we said, by wearing these yellow glasses, our archer will be able to hit the bullseye. Did we do that? No. No, we didn't. We were not able to do that. However, if all 3 of those shots are in the bullseye and all 3 of those shots are clustered together, then we can say that that's a very reliable and a very valid measurement of the accuracy or the effect with these yellow glasses. So, if your reliability and validity are things that are never going to go away, no matter what you're doing. You read an article about the latest, greatest infomercial. Well, you want to know if it actually does what it says it's doing. Well, that's validity. Okay, that's validity. You want to know that before you go out and spend the money on some new fad gimmicky toy thing that's going to help improve free throw shooting or strike throwing or improve your batting average, you want to make sure that it's repeatable. You want to make sure that you can use it over and over again and get good results. That's reliability. So we are doing it in our daily lives and we don't really know it. So again, some other examples. You have a pitcher throwing strikes. Are they consistently missing in the same spot? Are they all over the place? Where's the ball going? If they're reliable, if every time that you know they throw a slider, it's going to hit in the exact same spot every time, that's reliability. You know that. You can count on them. Okay, you can count on them. In basketball, the goal is to make a basket. If he or she is consistently hitting the front or the back of the rim, it's reliable. You know what? When they shoot this ball, it's going to hit the front of the rim. Brick. And you see that. You know. They're all over the place. You know that it's not reliable. That's in everyday life. You see this. You know it. You know it. You know it. You know when you walk in to meet with certain people what they're going to do, their mannerisms, how they're going to behave, what they're going to say to you. You know that if you walk into one of our administrators in the dome, he's going to shake your hand, put his hands on your neck, and squeeze your traps every time. Every time. Well, that's consistent. That's reliable. Okay, you can count on it. Now, there's various types of reliability. You have inter-observer and test-retest. Now, I've mentioned test-retest. Test-retest is I take an exam, I come back, I make a 92. And I come back and I take the exam and I make a 92. And I come back and I take the exam and I make a 91. And the next time I come back and I make a 93. And so I'm consistently being able to do that over and over and over again. Where inter-observer, you have multiple people observing the same activity and scoring the activity similarly. Now, let's say that we have a paper and I send that paper out to all of you and you each grade the paper and submit it back to me. All of your scores should be very similar. If someone graded it out as a 90 and then someone else graded it out as a 99 and then someone else graded it out as a 74, we have a problem. We do not have inter-observer or inter-rater reliability. So this semester, we're going to learn the math behind how to do that. Internal consistency. This is the extent to which each question in a survey measures the same phenomena. For example, if you're going to create a survey and you're wanting to know people's ability to recognize brands, brand recognition, you want all of the questions in your survey to basically answer the same type of question. You don't want them answering questions differently. If you want them to know, you want to make sure that you're very focused and everything's kind of streamlined. That's the purpose of face validity. Now, there are some threats to reliability. You have subject error, research error, and subject bias. Subject bias is probably the easiest one. That's basically giving responses that the subject believes the researcher wants. Sometimes we get that. Sometimes if you're interviewing somebody or you're working with somebody, they want to be successful. They want to succeed because they think that's what you want. They want to get stronger. They want to get faster. They want to make more shots. And so while the skill itself is part of it, maybe they're going to respond back and tell you, oh, no, this doesn't hurt. It feels good. I feel good. How are you feeling? How do you feel after this workout? I feel great. Okay. Researcher error, basically different methods in the same research project. Again, you fail to consistently perform the same thing over and over again. And then just pure subject error, because when emotion affects the subject responses. So if they're in a good mood, they're in a bad mood, again, you hate to let that happen, but that's human nature and it's part of the business. Now, let's get into validity, because I mentioned face validity and I want to make sure that we review that. Is what we think we are measuring actually what we are measuring? Okay. Basically, validity rests strongly on evidence. Okay, are we really doing this? Are we not doing this? To determine validity of measure, you have to decide on the nature and the strength of the evidence needed to make the judgment. Now, there are different components to validity. You have criterion validity, predictive validity, and then construct validity. So criterion validity basically assesses the extent to which a given model reproduces a given set of results. So again, it's very similar to what reliability would be, but we're now basically our results are going to show the same thing over and over again. Our predictive validity basically gives us an opportunity to forecast in the future based on what we know the results have been in the past. Where construct validity is the degree to which we are actually measuring and assessing what we intend. We use correlations here. How do we know that variable A affects variable B? Do two groups of data, are they actually related to each other? Again, we're going to use a lot of this semester is when we're going to do all the math for that. And then we get face validity. And I bring this up only because face validity is what you have to use when you create new instruments. So maybe we're measuring brand recognition using an iPad, and so we want to know how people are able to recognize that a certain brand is a partner with a company or a sport organization. Well, when we do that, we've got to send this survey out to professionals in the field and say, does this measure, this is what we intend to measure, will this survey provide those results? And if we get experts in the field to collectively agree, yes, this will measure that, that's how you establish face validity to say that this survey is valid, stamp it, move forward. Is it reliable? Yes, it's reliable, and we keep going, okay? Now, when using math, and again, the math on this it seems to be very difficult, but it's really not because your computer is going to do everything. Everything that you can show visually, and we've talked a lot about visual recognition, everything that you can show visually, we can confirm or deny statistically. And that's what we're going to have to get into this semester. So this will be a good review process for that. But again, reliability and validity as far as math goes, it's all right there. We're going to use Excel. Most programs, you're going to use SPSS. You guys don't have access to SPSS. Some of you might not. You're going to have access to Excel, all of you will. So we're going to learn how to do that. Now, that's kind of a very brief review on a very small portion of what we did last semester. But I wanted to hit those areas, especially reliability, validity, and your independent-dependent variable, to give you an opportunity to kind of hear it again. You may not want to go back and listen to that lecture again, but at least if you see this is a newer, this is the new 2.0 version, maybe you'll listen. I don't know. If you have questions, please let me know. Remember, this part of the course is the very beginning, and it's kind of one of those deals where we're going to take this review quiz, and from there, we're going to move forward, and we're not going to look back. So, again, if you have any questions, please let me know, and I look forward to grading your next homework assignment. Thank you.